I'm Ron Rasmussen from the Neely Sales region, and I'm going to talk to you a little bit this morning about power supplies. I've just seen the technical portion of the tape that you're about to see, and I'm very enthusiastic about it. I can say that I worked in staff as a staff engineer. I've worked out in the field as a field engineer, and the information in this tape, I think, was going to answer 95% of the questions that the customers are going to ask you. Now, power supplies are really not the most glamorous part of the electronics industry, you might say. But one thing that is glamorous about power supplies is the fact that everybody you see is a potential customer. Everybody you see has got to have a power supply, and if he doesn't buy it from you, he's going to buy it from somebody else. Now, we have got all sorts of technical backup data and information that we're going to go through at the end of this tape, which is going to help you, along with this information on the tape, I think, answer these questions for the customers and be more familiar with them. Now, last year HP sold $8 million worth of power supplies. Yet three other companies sold more dollar volume than HP did. Now, we'd like to get HP a little higher up on the list, and I think when you get through looking at this tape, then you're going to be in a good position to help us do that. So I hope you enjoy the tape, and we'll see you a little later.
Let's take a look at the first of several application problems your customer might have with power supplies. He has two power supplies in his lab, a 6296A rated at 60 volts and a 6206B rated at 60 volts. His question, how can I hook these together to give me a continuously variable voltage between 0 and 100 volts? Let's see how we can help him. In general, all power supplies with terminal strips on the back can be interconnected to give us current or voltage characteristics greater than those of any one unit. The auto series mode may be used to increase our voltage capability. The auto parallel configuration will result in a higher current source. In this first example, our customer needs to connect two power supplies in series so their voltages can be added. These power supplies have a total combined output of 120 volts. The outstanding feature of the auto series is that we can vary the output for both supplies by turning only one knob. The adjustable unit, called the master, controls the other supply, called the slave. Connecting these supplies in series would also give us 120 volts, but both supplies would have to be adjusted individually. As in any series circuit, the total voltage is equal to the sum of the individual voltages. This terminal strip on the rear of the power supply makes interconnection very simple. Operating modes may be easily changed by removing these straps and connecting the proper terminals. A valuable feature is that these connections can be made externally without getting involved in the internal circuits of the power supply. In addition, you don't have to worry about mixing model numbers in this connection. All models are compatible. The operating manuals for HP power supplies illustrate how to make these connections, or use this handy slide rule. Simply move the slide until the desired mode appears in the lower window. The terminal connections will then appear in the upper window. The other side of the slide rule automatically indicates further connection information. A note of caution: do not use auto series if the voltage requirement exceeds 300 volts. This is due to an insulation limitation within the unit. The auto parallel mode allows us to obtain more current than a single unit can provide. In this mode, the two units share equally the current demanded by the load, if and only if the two units are identical. In general, different model numbers should not be mixed in the auto parallel mode. Your customer may mix model numbers if he is not concerned about the exact amount of current he is drawing. Since the units are not matched, one will reach its maximum current value before the other. The combined output current then will be some value less than the combined current capability of the two units. Again, both supplies may be controlled by the unit which is connected as the master unit. Confusing buzzwords are often the source of many customer questions. Helping him understand power supply terminology may solve his problems and yours. Let's clarify the meaning of some of these terms. A constant voltage power supply is one which delivers the same voltage across the load regardless of the size of this load. We can check this by hooking up 2 meters to a simple circuit. As we change the load, the voltage remains constant. There will be a very slight change in voltage because the power supply has a finite resistance, typically 3 milliohms. The variation in voltage across the entire current range of the unit is called load regulation of a constant voltage power supply. In an ideal constant current supply, the current through the load remains constant, even if the load changes. In a practical power supply, the current will change slightly as the load is varied. This is known as load regulation of a constant current supply. But for now, let's stick to the ideal case. To achieve this constant current, our voltage changes in direct proportion to the load, or the voltage always complies with the load. This is known as the compliance voltage. Obviously, a compliance voltage is not just one value for one power supply, but is any voltage within the range of the instrument which corresponds to a particular load. In the extreme case of a 0-ohm load or a short circuit, the current remains unchanged and the compliance voltage is 0. Some supplies are referred to as current-limited supplies. In a broad sense, this means the output current is limited to some value that will not damage the supply. More specifically, current-limited is a term used to denote a class of power supplies that is well suited to applications where constant current is not a requirement. These supplies feature short circuit protection and are less expensive than constant current supplies. HP has a unique way of specifying the ripple factor. As you remember, ripple is the garbage composed of power line voltage and high-frequency noise which rides on our DC output. Because we have effects from two sources on our output, we use two terms in our specification. For example, a typical ripple spec might be 200 microvolts RMS and 10 millivolts peak-to-peak. The RMS voltmeter gives us a good indication of the power line voltage effect, but it cannot sense the noise, since high-frequency noise spikes are nearly averaged out. The peak-to-peak specification is particularly important for applications where noise spikes could be detrimental to a sensitive load, such as logic circuits. To measure peak-to-peak ripple, we must use an oscilloscope with a bandwidth of 20 megahertz or more. Including both of these measurements gives your customer a much better picture of which supply will meet his needs. Before we talk about what a crowbar protection circuit does, let's see why one is needed. Very frequently, a power supply will be capable of providing enough power to destroy the load. Unfortunately, many of our loads are much more expensive than just one resistor. Let's see what happens when we engage our crowbar protection circuit. Basically, this is a circuit which senses the voltage at the output terminal of the supply. If an overvoltage condition occurs, the crowbar short circuits the terminals, reducing the voltage to 0. At the front panel, we can set the voltage at which the crowbar circuit is activated. The range of the screwdriver adjustment is from 2 volts to 10% above the maximum output voltage. There is also an overvoltage indicator to show when the crowbar circuit has been energized. Crowbar protection is available as an option on most all HP power supplies. A few supplies include it as a standard feature. Refer to Application Note 109 if you need more detailed information about crowbar protection, including crowbar design and crowbar limitations. Here's another very typical application which might be brought up by your customer. We have a 6206A power supply and intend to use it to energize some circuits located in a room where nuclear physics experiments are being carried out. During these experiments, the room is off limit to personnel, so all of the equipment must be remotely controlled. How can we remotely program the output voltage? This is a natural for HP power supplies. There are two methods for remotely controlling the power supply output current or voltage. We may use a DC voltage as the programming source, or we may use a simple resistor, which we call a programming resistor. The value of the programming resistor, derived from the programming coefficient, depends on the particular supply. This programming coefficient, in this case 200 ohms per volt, is available on the data sheet and in the operating manual. The term 200 ohms per volt means that for every 200 ohms connected between the programming terminals, 1 volt will appear at the output. The resistance box is the most common way to program the supply. To make the output voltage continuously variable, some customers may want to use a wire-wound potentiometer. We can also control the supply output voltage by using a programming DC voltage. When we change our programming command, we cannot expect instantaneous response. A finite period of time is required for the output voltage to respond to our programming change. The up programming time is much shorter than the down programming time. When down programming speed is critical, use a lab series supply. These supplies are designed for high-speed programming. A special application of remote voltage programming, which is becoming very popular, is our line of digitally controlled power supplies. Because the supply must be interfaced with a digital computer, you should find out if your customer will be using an HP computer. If so, we need only a description of his equipment and his intended application. Otherwise, you should fill out this pre-interface form. Remote sensing should be used whenever the load is located at some distance from the power supply. Remote sensing allows us to maintain a constant voltage at a load, not just at the terminals of the power supply. It should in no way be confused with remote programming. The only similarity between these two completely different concepts is the word remote. Here's how it works. If a relatively heavy load was connected by a pair of long leads, the voltage across the load would be less than the voltage across our supply terminals. This is because of the IR drop through the long leads. The electronics in the power supply is designed to maintain a constant voltage across the output terminals. But what we need is for the power supply to provide a constant voltage to the load terminals. To do this, we remove 2 straps from the terminal strip and connect 2 more wires to the load. Caution: the sensing lead should be a shielded pair capable of carrying about 10 milliamps. The shield should be grounded at one end only, preferably the common ground for the system. It's also a good idea to twist the leads carrying the load current. It's possible, though unusual, to get oscillations when using remote sensing. Refer your customer to Application Note 90 for procedures to overcome this problem.
You'll remember at the start of this tape we mentioned that Hewlett-Packard was 4th in the power supply manufacturers list last year. We're going to discuss some tools and show you some data sheets here which are going to help get HP up out of 4th place, we hope. Now, the first thing that I'd like to point out to help us get out of this position is the warranty rate. The warranty failure rate. The New Jersey division only has a 6% failure rate in the last year as opposed to the corporate 12%, which I think in itself is a real sales tool right there. Now, let's review some literature that we've got here, and we'll see just how this literature can help us. First of all, the general catalog, which I'm sure all of your customers have. We'll take a look at the power supply section here. And you'll see that we have 113 models of power supplies and 19 different series. Now, the series are listed here in this little box, and the various power supplies listed by output voltage are shown on the next several pages, which makes a nice selection guide. Now, in addition to this, another sales tool which I feel really helps sell a power supply are the options. We've got a number of options which allows the customer to just about order any configuration that he wants to, and he doesn't have to fool around with specials like he might with some other manufacturer. The options are listed back here, as well as the rack mounting information shown on these pictures down here, which makes the supplies very convenient for rack mounting. Now, in addition to the general catalog, we have a power supply handbook here, application note 90, which is very helpful in describing how the power supplies operate. And I'm sure that the customers are going to find this very beneficial to getting a better inside knowledge on what's going on in the power supply. And then we have the 1970 DC power supply catalog, which has combined essentially the 1970 green or blue catalog there and the application note so that it's all in one book. And I have a piece in here on page 3. You'll see a sheet which lists the models numerically and which page of the catalog they're on, which is very helpful, as well as the condensed listing of power supplies by voltage, again, as we saw in the general catalog. This is a very helpful catalog right here. Next, we have a service note called the DC Detective. This helps the customer find various defects if one should show up in the power supply, various problems, helps him troubleshoot the power supply. But I'm sure with our 6% failure rate that he's not going to be using this book too often. And next we have application note 109, which was described in the tape. It describes the crowbar and how the crowbar circuits work and how the customer can apply crowbar circuitry in his application. And the last one that we have here is a company confidential book called Competitive Comparisons of DC Power Supplies. Now, I think you're going to find this very helpful in bidding competitively against other manufacturers, as well as preparing quotes and this sort of thing. What you're looking at now is a condensed data sheet, which we call a power supply selection guide. Now, as we mentioned earlier in the tape, every customer that you meet is a potential power supply customer. And therefore, when you're out making a call and the conversation lags, or you're making a cold call and you don't know what to talk about, reach in your briefcase and get a power supply selection guide and hand it to the customer. He's going to have something there that he's interested in. He's going to probably put it somewhere where he can reach it when he wants a power supply, and that really is what's going to cause him to buy HP supplies, as if that list is close by. So let's remember what we've seen on the tape here and try and bring Hewlett-Packard's name to the forefront in the power supply field and get us up from fourth place up to first place.